Okay, so first you're going to skip ahead through a couple foldables that you guys have already mastered those skills. We don't need to do the foldables, they're a little out of order. So please get to this foldable right here. Pause until you're there. Okay. So this, first of all, the center part. What you need to remember, like this skateboard, keeping his balance, I always use a scale. What's the goal? The goal is to isolate the variable while keeping the equation balanced. We want to keep that equal on both sides. So, and remember, just like you've been doing, whatever you do to one side of the equation, you have to do to the other. There are small, tiny exceptions to that. And let me talk about that real quick. So here I have my scale. And let's say I've got these shapes, and they have different weights, right? So these 3 circles, these 2 squares, that square, and that cylinder. Okay. So you already know I can add a cylinder to one side, and if I do that to keep my scale balanced, I have to add a cylinder to that side. Don't know why I would want to do that, but I could. Okay, so let's undo that. I could also get rid of one of these boxes, right? And then if I do that, I've got to get rid of a square on that side. Okay, so now my equation is balanced. Could I, without messing up my scale, could I move that circle from here to there? Does that change anything? No, it doesn't change anything. My equation is still balanced. I can move that around. Could I, with my super ninja skills, take this box and just evenly slice it into halves, 2 little boxes? Sure, I could do that. That wouldn't affect my overall scale. So yes, we say that what you do to one side, you have to do to the other. But really, we're talking about multiplying, dividing. We're talking about changing this expression. If you just change it to an equivalent expression on this side, then you really haven't changed the expression. You've just rewritten the expression. And in that case, you don't need to do something on this side. Okay, so that might be a little abstract. We'll see what that actually looks like. So here we go. Here we have 3t plus 5t minus 5 equals 11. Okay, well, we've practiced this. If I have 3 boxes and 5 more boxes, do I really need to talk about them separately? No, I can combine those. So the first thing when I'm dealing with multi-step equations is I'm going to combine like terms. So 3t plus 5t gives me 8t. Then I copy down the rest of the equation. Minus 5 equals 11. And then you've solved these before. I want to isolate my variable t, so I'm going to add 5 to both sides. I'll get 8t. The negative 5 and the positive 5 will cancel out, equals 16. I want to keep isolating for t, so I'm going to divide both sides by 8. 8 divided by 8 is 1, so I end up with t equals 2. Pause if you need to talk about that. Alright, go ahead and see if you can do the next one with a neighbor. You can pause me until you're done. Alright. So, first thing I did was I combined my x's. 8x plus 3x is 11x. And then I also combined my constants. Positive 6 and negative 2 is going to give me 4, equals 37. Now I'm going to subtract 4 from both sides. I get 11x equals 33. Divide both sides by 11, and I get x equals 3. Okay, so we can rearrange this expression all we want because that doesn't change anything. But then once we start actually adding or subtracting or multiplying or dividing, then we need to do it to both sides. Okay? All right. Down here. Oh, okay, we've got grouping symbols. We haven't had those before. So what am I going to need to do before I can really work with this, before I can isolate my A? Because look, I've got an A inside the grouping symbol and I've got an A outside of the grouping symbol. We're going to need to distribute this 3 first. So we're going to need to rewrite this as an equivalent expression. So I'm going to distribute. I've got 5a. Oh, that's going to stay the same. So I got 5a. Well, positive 3 times a is going to give me plus 3a. Positive 3 times positive 2 is going to give me plus 6. And that still equals 22. What do you think I'm going to do next? Right, I'm going to combine my like terms. 5a plus 3a is going to give me 8a. Copy down the rest of my equation. Plus 6 equals 22. Now this is old hat to you by now. I'm going to subtract 6 from both sides. I'll get 8a equals 16. Divide both sides by 8, and I'll get a equals 2. Not too complicated, right? Just a little extra steps. Now we're at multi-step. Okay. Okay, so let's... Ooh, this is looking kind of ugly. Now, I could subtract 7/4 from this side and from that side and then deal with that. But you know what? Let's go ahead and multiply this by 4 so that I can get rid of this fourths. And what you're going to see is kind of cool. And you're going to want to remember it for the future because it'll help you in the future. So I'm going to multiply this side by 4 and that side by 4. And remember, you can think about it as 4 wholes if it helps you. Okay, so now I've got to be very, very careful when I distribute. 4 times 5n over 4. Some of you already see the cancellation. If you don't, then you can think about it. 4 times 1, 4 over 1 times 5n over 4. I can cancel out my 4's, and I'll get just 5n. Or you could actually multiply it out. 4 over 1 times 5n over 4, that's going to give me 20n over 4, and that'll reduce to 5n. It's going to be real. The sooner you can master canceling, the better. You're really going to need that. But in any case, so 4 times 5n over 4 is just going to give me 5n. Now, if I distribute that 4 to 7/4, you can think about that already. 4, if I have 7/4 and I do that 4 times, I'm just going to have a whole 7. But you can also do the math for that. And you can do the math for that a different way. Either way, you're going to get plus 7. Okay, equals... And now I've got to multiply this. 4 times negative 3/4. Do the math if you need to, but you're going to get negative 3. And now look how much easier this is to work with. We've basically just gotten rid of all the fractions. Pretty useful. And later on, if you have different denominators, though, we'll talk later on about what to do if you have different denominators. As a shortcut right now, just deal with them as fractions because I've done the homework already. It's not that bad. But in the future, there'll be a way that you can cancel out all those fractions. But for now, a nice, easy preview into that. Okay, really simple to solve. I think you can do that with your neighbors. Go ahead and pause and do it. Okay, so I subtracted 7 from both sides. I got 5n equals negative 10. Divide both sides by 5. I get n equals negative 2. And if I was doing my homework and was unsure of my answer, I would probably want to substitute this in and make sure that this gives me a solution. That this does really end up being an equation that works. Okay, let's move on. Yes, we're doing quite a few notes today. So, on to this foldable. We're going to solve an equation with variables on both sides now. Okay, scary, scary, scary. Not really. Not scary at all. But remember, our goal is to get the variable all alone, just one of it. If we have the variable on both sides, we won't know what the variable equals. So, how can we get the variable on one side? We can either move this over here or move this over here. What can we do? Well, what have we done when we're dealing with a number here that we don't want to have over here? We just add or subtract or multiply or well, we add or subtract. Whenever you've got variables here, right now just add or subtract those variables. So let's do that. And as a general rule, it's easier. I could add 8x to both sides, but then I'll have all of my x's on this side. So just to keep it simple, let's just go ahead and get in the habit of collecting our x's on the left, our variables on the left. So to do that, I want to get rid of this 4x. I'm going to subtract 4x. If I do that on this side, I need to do that on this side. So I'm going to subtract 4x here. Okay, so now, well, my 7 doesn't change, so I'm going to bring that down. Negative 8x minus 4x is going to give me negative 12x. And that equals, well, 4x minus 4x is 0, right? So that'll cancel out. And now I have my negative 17. Just bring that down. There we go. Now I have an equation that I'm used to solving. Get rid of this number. So I'm going to subtract 7 from both sides. I'll end up with negative 12x equals negative 24. Divide both sides by negative 12. And I end up with x equals 2. And if I want to be sure, I can substitute it in. Okay. Solving an equation with grouping symbols. We actually already did this, but again, we've got variables on both sides. Go ahead and try that with your group. Pause and then play when you're ready to go. Okay. So I just rewrote the left side because there's nothing here for me to rearrange. This is as simplified as this expression is going to get. But I'm going to simplify this expression. So that means I'm going to distribute this term. 1/4 times 16x is going to give me 4x. 1/4 times 60 is going to give me 15. Now I want to move my variables to this side. Well, basically just get rid of my variables from here. So to get rid of 4x, I'm going to subtract 4x. Oops. I gave it away. Go ahead and try this on your own. Oh, you already did, huh? I'm giving you a chance to redo it if you need to. All right. So I'm going to subtract 4x here, as I already said. So then I have to subtract 4x here. I'll end up with 5x. I still have that minus 5. That hasn't changed. Equals 4x minus 4x is 0. So that just equals 15. Add 5 to both sides. I'll get 5x equals 20. Divide both sides by 5. I'll get x equals 4. Not too bad, huh? Okay, this is going to come as a left hook here. Word problem. Ooh, you guys get to write an equation with variables on both sides. Okay, first there's a small typo here, so you might want to fix that. Go ahead and pause, and I'll give you a chance to read that. Actually, you don't need to pause, because you're going to do this as group work. Here's your hint. You're going to write an equation with a variable on both sides. If you need another hint, play, and I'll give you another hint. Otherwise, pause and work it out. Okay, I don't know if you're here for the hint or if you've already got a solution, but if you're here for the hint, here it is. Let y be the number of years. That's the variable you're looking for, is how many years. And you're going to have a y on both sides. Okay, pause if you need more time to work on it. Okay, you ready? All right, let's see how you did. So I'm looking for when new is equal to, the number of new cars sold is equal to not the number of used cars sold, but twice the number of used cars sold, right? Okay, so let's work on both expressions separately. So how are the new cars changing? Well, I'm starting out with 78 new cars sold in year 0. And then every year I sell 6 more cars. So plus 6 cars times the number of years. Okay, so there's my new car side. My used cars, how is that changing? Well, I'm starting at 67 cars. And then I'm not adding, but I'm subtracting 4 cars times the number of years. Okay, but do I want to set these two equal? No, I don't, because I'm looking for when this is equal to twice this. So I've got to add that, multiply this side, this expression, by 2. And now I'm looking for when this expression is equal to this expression. Okay. If you didn't get to this point and want to pause now and get this worked out, you certainly may. Okay, so 78 plus 6y, I'm not going to change this, but I do need to distribute this side. I need to simplify the right side. So I'll be distributing. So the left will still be 78 plus 6y, and the right side is going to be 134. 2 times 64 is 134. And now 2 times negative 4y is going to be minus 8y. All right, I want to collect my variables on the left side, so I'm going to add 8y to both sides. I'll get 78 plus 14y equals 134, and my negative 8y and positive 8y cancel out. Now I need to collect all my constants on the right, so I'm going to subtract 78 from both sides. That cancels. I'll end up with 14y equals 56. Continue isolating for y. I'm going to divide both sides by 14. I'll end up with y equals 4. Now, before you pause, I want you to think about, how can I check whether this is my correct answer? Because if I plug this in, if I substitute my solution into this equation, well, all that's going to tell me is whether this equation works for that solution. That doesn't tell me whether this is right for this word problem. So pause and talk to a neighbor. What could you do to see whether this solution is correct for this situation? Okay, I don't know what you came up with, but here's a suggestion that I would make when you're in this situation, is I'm going to make a table. So here's my table, and I'm going to have for each year how many new cars were sold and how many used cars were sold. Because if I'm correct, then in my table by year 4, the number of new cars sold should be equal to twice the number of used cars sold. So let's see if that works. Year 0, I start with 78 new cars and 67 used cars. That came right from here. Okay, in year 1, well, my new cars go up by 6, so I have 84, and my used cars go down by 4, so I have 63. Okay, year 2. New cars go up by 6, so I have 90. Used cars go down by 4, so I have 59. Year 3. Ooh, I'm going to run out of space. There we go. Okay, year 3. New cars go up by another 6, I have 96. Used cars go down by 4, so I have 55. Year 4. Here's where I should get that double. New cars go up by 6 more, I have 102. Used cars go down by 4, I have 51. Is this twice this? Yay! So we have the correct solution. It is in year 4 that the number of new cars sold will be twice the number of used cars sold. Nicely done. Okay. The very last flap, oh, sorry, so yes, that is correct, so therefore that is correct. Okay, the last flap we're actually going to save for Friday. So have a great rest of class, what is left of it, and I will see you tomorrow. Bye.